Welcome to Clean Titans. Today, we're looking at a truly innovative technology that could revolutionize how we generate clean energy. We have with us Jonathan Hafemann, VP of Commercialization, Next Energy Technologies, a company developing transparent solar cells. Jonathan, welcome to the show.
Thanks, Ellie. It's great to be here.
We're thrilled to have you. Next Energy Technologies is working on something truly groundbreaking. To start, could you give our audience an overview of Next Energy Technology and its mission?
Yeah, Next Energy is developing the world's first fully transparent solar panel, basically, that can be integrated right into a window. So, our mission is to turn commercial buildings into clean energy generating assets for a building. And we do that through our unique proprietary organic photovoltaic coatings that go right onto architectural glass and basically turn the outer pane of a window into a solar panel. So that's it. That's what we're doing.
The concept of transparent solar cells is fascinating. Can you explain the technology behind Next Energy's transparent nano coating and how it works?
Well, the technology is not my area of strength. I'm commercial. What I would tell you is that within the world of solar technologies, organics has been, I would say, a an area that has been overlooked and has maybe been even discounted or dismissed a little bit. What a carbon-based semiconductor allows you to do is it fundamentally allows you to do something none of the other silicon or any other the solar technologies out there, which is enable transparency. So organic chemistry and organic PV materials give you fundamentally unique advantages when it comes to this type of application that enables transparency. It gives you tunability, which is both for performance and for color, which is a critical aspect of putting a coating on a piece of glass because that architects have a lot to say about the aesthetic of a building, and if they don't like the color, you're not getting on that building. I would say that organics are uniquely suited for the type of applications that we're pursuing for building integrated PV. The other, I would say, unique aspect of it is that it performs really well in what we call facade friendly applications. So that is a vertical standpoint with off angles and low light conditions that are typical in a vertical application like that, where other solar technologies need higher levels of resistance to generate power. When they get into off angle light conditions, they stop generating power, and OPV will continue to perform even at a lower efficiency, admittedly, but it can generate power for a much longer period of time in the kind of conditions that you would have off angle and high heat conditions on a facade. So while OPV is maybe not the darling of solar technology broadly, it is uniquely well suited for the type of market that we're pursuing to transform the facade of a building into a solar power generating asset.
What are the key differences between Next Energy's technology and traditional solar panels?
Well, I can't speak to that at a structural level. What I would say is like the big one that people are going to point to is efficiency. So when you have a silicon wafer that is fundamentally solid state, right? Its only job is to absorb the spectrum of light and convert it into energy. Your efficiencies are much higher. You're in the 21, 22, 23% range on a solar panel with silicon or maybe even CAD-TEL. But for us, because we're transparent and we're using a much more limited material set for solving for that color and visibility aspect of the hey, how does it look on a building? How does it look to look through it from the inside of a building out? Those factors were in an efficiency range that's much lower. So we're in the 3.5% or 35 watts a square meter type of range. So I'd say the biggest difference besides their function and application is going to be your efficiency. That's what people are going to, I think, notice the most when they compare the standard solar panels to this type of technology.
You've achieved a significant milestone with the world's largest vision glass with a transparent photovoltaic coating. What does this achievement signify for the commercial viability of your technology?
Means we're on the path to full scale commercial production. So for us, the next big step is a full-scale commercial line, and getting our coating onto a format of about meter by meter and a half or 40-inch by 60-inch is a really big deal for the glass market as a whole, because getting coatings, scaling your coating process onto large format glass is really a key indicator of the viability of the technology. In addition to how does it, like, once you've coated it, of course, you have to run through the battery of kind of standard industry tests for both solar and for glass, and glass performance. But for the people that know glass and that know what it takes to get glass or coatings that are uniform, that perform well, and that pass the eyeball test, that's really hard. It takes a long time to do that. And so for us, it's a major validation of the scalability of the process that we've developed, as well as the core underlying technology.
What are the next steps in scaling up production to meet commercial demand?
Yeah. So a couple things at the product level, we need to get UL certification, and then also the ensuing glass industry certifications. And that's a unique process because UL's never certified
Mhm.
anybody with our technology.
Right.
And so we're in a in-depth, lengthy discussions with them right now about the approach and how they want to handle it, and then what that is going to look like from a testing process standpoint. So at the product level, we need to get clear all of the right safety and performance certifications. At the process level, we need to make sure all of our processes are going to translate to working on our pilot line right now will translate to commercial scale processes, so that there's not a major bottleneck that emerges once we go to try to do this at full size and full speed. But then on the commercial side, there's the reality of, hey, we need to create access to the floor, the space we need on a fabrication floor to stand up our line. So there's a few ways we can do that. We can outright license the technology to an existing player in the industry. We can buy a fabricator and leverage their existing facility and equipment to gain access to give us control over a space that we can insert our technology into. Or we can work with a friendly fabricator who has space on a floor and likes what we're doing and wants to rent us space, and create a supplier agreement where they can sell us materials that enable us to build full size lights. So we need to solve for that aspect of the equation. Once we have that, we're going to be 18 to 24 months away from something approaching full scale production. So those are kind of the big, I would say, milestones ahead
Miles.
of us to clear.
Transparent solar cells have a wide range of potential applications, from windows to facade. What are the primary target markets Next Energy is focusing on, and why?
The first market is going to be commercial facades in the US. And the reason is that there's really rich incentives within the ITC that allow us to, I would say, de-risk the sale of our technology into a facade. I would say if you learn anything about the glass industry or the commercial building built environment, and you've learned anything about facades, which you know is what I've come to know and understand about the facade market is that it has really three mandates that are very clear within the facade market, at least in the US. It's reduce risk and reduce risk. It's a very conservative, low risk type of environment. And usually the only way that things change in that market is when there's code changes. And so when you take a new technology into a space like that, you have to have a value proposition that's so compelling and that has a path to de-risking a developer's investment, and that makes it easy for the folks with downstream of the developer, the architect, the general contractor, the glazer, the electrician, to work with your solution and make it easy for them to say yes. The developer is the one who has to say yes on the financial aspect of it and bring that to bear on the project. But then everybody else also has to say yes and agree to want to pull this through. If any one of those folks, the GC, architect, glazer, or electrician, says no, everything stops until you can get them back onto being a yes. So those are the challenges that are involved in selling a technology like this and gaining traction and adoption. And so, with the kind of incentives we have with the ITC, which enable with a domestically produced solar technology up to 40% tax credit against the entire cost of the facade. So, the glass, the metal frame, and the labor to install it. that creates an environment that is really rich for early adoption and creates time and runway for us to build our market, mature our manufacturing processes, and mature the underlying technology to improve the power efficiency and then expand into other markets. So from there, we could look at things like potentially niche residential applications. Expanding into Europe would be a very, I would say, easy next step. It may, in the end, even be our first step. We'll see how things kind of play out from a demand perspective. But Europe and Middle East certainly look like really, I would say, high quality markets as a fit for our technology. And so, from a strategy perspective, that's how we would anticipate the rollout of this kind of technology.
Yeah, you can get a contract with the Mile city in Saudi Arabia or Masdar city in UAE.
Yeah, I'd prefer a project that more likely to happen than not, but it's certainly good marketing if you can say you're selected for the mile.
Right. All right. Are there any other potential applications beyond buildings that you're exploring?
Yes, there's some niche, I would say niche applications that we're working on, like things like solar powered garage doors, things that kind of maybe a hybrid market, like could work in a residential or a commercial application, and that have some very definable value propositions. Glazing like skylights is definitely of interest as well. And so I'd say there's some other markets that we would say are smaller that are well optimized for us to build off of our pilot line that we could supply into that are small format, lower risk type of installations, not hanging on the 10th story of a building, right? That you could, if you needed to, you could service it pretty easily. So we're definitely have some of those going on. They're not going to be meaningful from a volume perspective, but they'll be meaningful from a market traction, adoption, signal market interest type of perspective.
So you would put the coating on garage doors?
And our coating goes in between two pieces of glass. It's just like a standard solar panel in that regard. So our architecture looks just like a solar panel, but we use architectural glass instead of the thinner, lighter type of glass you would use in a solar panel. So,
Okay, so it'll be the
um,
glass panels in a garage door that
correct.
go in there.
Yes, we would
Got
just take. So you take basically two pieces of glass, you laminate them together, you glue them together with our coating in between, and so that's what would fold into a garage door or a skylight, something to that effect.
got it. One of the key advantages of highlight is exceptional aesthetics. How does the transparency of your solar cells compare to regular glass? And what are the implications for building design and aesthetics?
So there's a few different aspects to traditional glass coatings. There's the color, there's the solar heat gain performance. So how well does it reject heat that's trying to get into the building to keep when you're in your cooling months and you need to cool? How well does it keep heat out? And then when you're in your winter months and it's cold outside, how well does well does your IGU or insulated glass makeup when you've got a heat inside and cold outside, how well does it manage that thermal situation? So those are the kind of three core performance metrics aspects of glass performance, like basic. There's a lot more to it than that, but for us, and then the other one is like, as you would imagine, the more layers of coatings you add to a coating stack, in order to get better and better performance, the darker and darker that coating gets, and the lower and lower your what's called the visible light transmission becomes. So for us, we're modeled around what is considered a widely adoptable color. So our color is it's probably reflective of the type of coating that gets selected about 70 to 75% of the time on a building in North America. So we're very well aligned there from a color perspective. From a VLT or visible light transmission perspective, we're a little bit darker than I would say maybe a standard coating in that color range. And so we would be really well, I would say our coating would be really well or commonly used in markets like Texas and the South, Arizona, places where you've got high sunshine and high heat gain. And so we would be in line with a market kind of range of about 30% visible light transmission. If you were in a northern climate, like let's Seattle or somewhere up north where you've got a lot more gray, cloudy, less sunny days, Typically, people want to see a VLT in the range of 55% in those types of markets because there's not as much sunshine, there's not as much light coming through, and there's not as much heat gain to manage. So they don't need as many kind of that stack. So I would say we're well suited for, very well tuned for color adoption and very well tuned for the type of VLT expectations you would have in a southern market in the US.
So the plant sand will be okay, and people inside would still get vitamin D, right?
Certainly. Not it, but it's always advised to get outside, get that sunlight in your eyeballs, okay?
Right. I'm
Follow
sure
the
some.
follow
I'm
the Andrew Huberman protocol, right? First thing in the
right.
morning and late in the afternoon.
Right. Just wanted to throw that in there because some people would wonder. How do you address concerns about the efficiency of transparent solar cells compared to opaque ones?
I mean, just say that it's just the necessary trade-off you have to make for, the market we're going after. I'm not We can use OPV to make opaque cells, and we are working on that for coatings in the spandrel area, which spandrel area is just the glass. Most people who don't work in glass would ever notice this, but when you are in a building, there's glass that is sit covers up the concrete in between floors. So there's the glass you can look through. That's your vision glass, and then spandrel glass is what sits in between the floors, covers up your concrete on a building. And so in that application, we're developing coatings that have higher efficiencies that are closer to 0% VLT or opaque coatings. We have that flexibility with OPV, but we're going to have some limitations on efficiency, but certainly be much higher than 3.5%. You'd be in the 9, 10, 12% range, sort of application.
As VP of Commercialization and Growth, you're focused on bringing this early stage solution to the market. What are the key challenges in commercializing new technologies like transparent solar cells?
Well, this is my fourth startup, fourth time kind of down the path, taking a new technology into the built environment. Learned is that the probably the hardest market to do it in is glass. It's a very very space to bring a new technology into. It requires a lot of factors kind of to gain adoption. So where my focus is I would say my skill set and my specialty is industry focused. So there's sort of two dimensions to this effort. I would say there's the industry facing side and then there's the market facing side. Market facing side is calling on developers and architects and building your pipeline of the sales channel. What I do well is anyway, and for a while I'll be doing both, but I would say my focus is, or my skill set is best attuned to the strategic side of it, of working with players in the industry, building interest, establishing credibility, and figuring out who long term wants to run with us with this technology. So that's very much more licensing, business development, strategy, industry relationships. And that's what I do well. That's my kind of language. And until we're ready to bring on somebody full time to who's a salesperson who just loves to go out and fill the funnel and call and present and make dope. We're doing both for now. You need both to build the market. And, once we have enough credibility that the glass industry says, hey, we think this is ready for us to kind of then be looking to kind of pull the big lever and take us up a notch beyond what we could do on our own as a startup.
How are you working to overcome these challenges and build partnerships within the commercial glass industry?
Look, it's really things. It's a trust building exercise. So you have to win the trust of the commercial market. And you do that by doing what you say you're going to do when you're going to do it, when you said you're going to do it, and then creating a product that has appeal and interest to their market. And so it's understanding the value proposition there, what interests are, and what enables them in their business model to sell more and make more money. And so that's really what it comes down to. If you can figure out how their business works well enough to understand how your product or solution can add more value to their bottom line, and either or give them a competitive advantage in the market, that's how you're going to win. So that's the general strategy, the approach. It varies a little bit by company and what their goals are and what their place in the market is and all those other things. But I would say generally that's kind of the approach I'm taking.
You mentioned seamless integration into existing glass manufacturing
Mhm.
process. How does Next Energy work with glass fabricators to ensure a smooth transition to using your technology?
Well, the idea is that for our technology, traditional glass coating technologies are applied at the float glass level. So float glass is when you create these massive sheets of glass that float on molten tin and come out in high volumes. So like the float glass manufacturers, they ship standard size product that is like raw materials, not something you could install on a building, and they ship that in high volumes to fabricators, and those that glass comes with a coating applied to it, and they have a variety of different types of coatings, but those are called low E coatings. Those coatings sit on the glass and they're able to be cut down and then run through a tempering process where you heat strengthen the glass in a giant oven that processes the glass. So for our technology is not able to sustain exposure to the high heat environment of a oven. So where our technology has to get applied is after you've taken raw glass, you've cut it down to size, you've run it through the oven, and then it gets coated with our product. So that means that unlike traditional coatings that you have in Windows today, our product is really not meant to be sit with the guys that make coatings right now. So fabricators are good at the cutting and heat treatment and gluing together and assembling a finished product. So where we fit in is after you've cut heat strengthened glass, it's going to come down our line, and then we're going to have a special process to both coat it and then laminate it and glue, create the hermetic seal that you need to protect the coating and glue it together. It's called a laminate. That is a process that we will work with the right fabricators to either train them on, or if for some reason they figure out, hey, this isn't a process we're good at managing, to manage it ourselves and run and train our own line. So I would say there's a bit of like where we end up will determine a little about the how and how we do that. But generally speaking, our belief is that the fabricator that is interested in our technology is going to have the ability to learn how to manage that process on their own with our help and support along the way to adopt management of that line.
Add this additional line to their process.
Correct. Yep.
What are the cost implications for glass manufacturers and end users of incorporating transparent solar cells?
So for at the glass level, it's about a 4x increase in cost. Now at the installed level, so when you say the install, like typically if you were to install a laminated insulated unit on a commercial building today, you're at the $120 to $130 a square foot fully installed. So that's glass, metal, and labor. Glass is typically 15 to 20% of that cost stack. Your biggest costs are metal and labor to hang glass on a building. And so we're going to add, approximately to the cost of the glass. So we'll drive your kind of up to somewhere in the range of $185 a square foot. Call it that. Now, again, with the tax credits, and that's also at a high margin for the fabricator and for us, right? It's to be a good business model for our licensing partners and for the manufacturing and technology risks that they're taking on. But for the adopter, for the end user, right, when you apply a 40% tax credit against that value, and then you add in all the other benefits, the energy generation, the gains in efficiency, the improved building performance, all that stuff, all of that is basically nets out to a sub 1 year ROI for a developer. So it's a very compelling value proposition. The cost is higher, no doubt, but the initial value is significantly greater than the additional cost. The goal is by the time those incentives expire, early 20, they call it 2032, somewhere in that range, that our efficiency of our solution will be high enough that the economics will sell on their own, just like we saw in other kind of traditional solar adoption curves of like needing to approve over time. So that's our expectation, and our goal is to see that we can show a path to both the market and to our investors that includes us selling our solution based on standalone economics.
What are the key performance metrics that building owners and developers should consider when evaluating transparent solar cells? And how does Next Energy measure up?
It's hard to say because this market right now is so small. There's not many people doing BIPV. So it is and when I say BIPV, for those who are not in the facade world, I mean building integrated photovoltaics. So that it's just a little murky right now to say exactly. I would say the initial reaction is usually efficiency, and ROI. Those are kind of big drivers for developers. Developers are very sophisticated investors. They're car investors, and so they the financial language fluently, and that's those kind of their I think where their mind goes pretty quickly. And then after that, it's additional financial metrics like how does this improve the marketability of my building? How fast can I lease it up? Do I get a premium for leasing? Or, get a premium in the market, an extra 20, 25, 30 cents, 50 cents a square foot for having a solution like this in my building. So it's all about the financial justification with the developer.
How does your technology contribute to achieving net zero building standards?
So our modeling is based on our efficiency today. We're going to account for 20 to 25% of a building's electricity needs. So I would say that we're not the solution. There is no one solution, but we're a part of the solution to net zero. And net zero on taller buildings is just extremely difficult. So it's going to be a myriad of solutions that come together to enable net zero tall commercial buildings that are highly glazed as well. It will be things like glass technologies like VIG that are highly insulating. It will be include gains in efficiency on HVAC systems, cooling, radiant barrier, geothermal, solar, wind. I mean, those things will play a role in becoming net zero, but there's no one product is going to be a silver bullet to a net zero. So we're going to make a contribution, but we're not going to get you all the way there.
Well, there are some hotels and some big buildings that are trying to be very close to that. So hopefully you can
Yep,
help them.
certainly.
You're preparing for key installations in US and Europe and working with the UL certification. What
Mhm.
is the timeline for these milestones and what impact will these have on market adoption?
So I would say UL certification by Q1 next year and full commercial production within 2 to 2.5 years from today. And then we should have at least one major, hopefully two larger installations under our belts by then in the 3 to 5,000 square foot range. And then filling the funnel on the top of the pipeline. I mean, haven't anything keyed up in Europe yet? Everything in Europe is very exploratory on the industry side. So it's all commercial glass industry that we're talking to there. We're not really dealing with end users or pipeline or project development work in Europe. So at this stage, certainly that can change very quickly. But that's I would say roughly the timelines we're looking at for the questions.
What are the regulatory hurdles you need to navigate in different regions?
The one we have to work through, I think, still as an industry is the rapid shutoff requirements for solar power, fire code standard. That is a challenge for us to navigate with both our balance of system, our inverters, and having those capabilities integrated at the system levels. So for us, that's a big one I think that we're working through because it doesn't really make a lot of sense that the minute you break glass, it's going to stop producing power. If you're a firefighter, the chances of you going through a window to get into a commercial building as a firefighter are very extremely low. It's sort of standard that doesn't seem to quite fit. It's like a holdover from I'd say prior standards that had applicability, but in this new novel application is not really those codes aren't really a great fit. So we're definitely working with folks to try to address that aspect of to make adoption easier.
How do you see transparent solar cells fitting into the broader landscape of renewable energy technologies?
Within the broader landscape, every technology has a role and a place, right? We're not trying to compete with rooftop solar or solar on top of your parking garage, or you need to put as much solar as you can on these buildings. We see ourselves as complementary. So once you've done your rooftop solar and you've put it on your parking garage and wherever else you can put it on your project site, you still need more. And so we're the next bite down. So we're saying, hey, you've got all this square footage. It's existing infrastructure. You're putting it in anyways. Let's empower it with a solar coating like OPV and give you a little bit more push towards your goal of being a net zero building. So for us, we see ourselves as complementary in the landscape. We're not competitive.
What role can BIPV, building integrated photovoltaics, play in accelerating the clean energy transition?
Like I said, it's complementary, it's additive, it's leveraging the existing infrastructure that you're already paying for with a little bit additional cost and additional benefit and value. So, that we're headed towards a future where at some point in the next 10 years, we're going to cross over to where most buildings being built are going to include solar technologies that will contribute to this being sustaining renewable power that can be eventually serviced and serviceable, but only is going to be one of the bigger growing niches within the glass market in the coming years.
What are the biggest technological advancements you foresee in the transparent solar technology in the next 5 to 10 years?
I'm not a great guy to ask that question. I don't have a great feel of the technology pipeline and landscape. He would be the right guy to ask that question too, Corey.
I know. I
He's a
wish we had him.
I know he's a giant solar nerd and he just the stuff and is really good at it. And so I that's a little outside of my scope. So we'll have to get Corey on another day.
Okay. How Next Energy investing in research and development to stay at the forefront of this technology?
Yeah, so we're continuing to invest in materials research. So we have our R&D lab where we're working on, like I said earlier at the start, the tunability of OPV is our core strength. So we want to invest in new product lines that can enable us to do things like maintain our current efficiency, but increase the visible light transmission. So there's markets in Northern Europe, for example, that really want a 50 to 55% VLT because in France and Germany and other places like that, they don't get as much sunshine as they do in Italy and Spain and the southern European markets similar to the US. So certainly that's of interest. I think that expands our market both in the US and it opens a door for us to get a product line launched in Europe. And then similarly, how can we maintain our VLT while improving our efficiency? And then there's this other, how do we put a coating like ours into a spandrel cavity, which is a inherently harsh environment? It's very high heat. Typically, spandrel cavities are not vented, so they generate and produce very high temperatures in the inside the IGU and behind the IGU. So developing materials for those types of applications is critical to our long-term success, and we're invested in that. We've even got a grant application in with the California Energy Commission to help fund and advance some of that research. So we're very excited about that.
For building owners, architects, and developers looking to incorporate transparent solar into their projects, what advice would you give them?
That's a very complex topic, and I would say reach out to people who know who have a long history working with BIPV and can guide you on how to apply the principles of integrating and the best practices of integrating solar in your project. That would be my best advice.
How can they connect with Next Energy Technologies to learn more?
Yeah, Jonathan, nextenergytech.com, easy to reach. And our website's nextenergytech.com. We have a ton of information on our website about our technology, our story, our growth, our vision, and where we're headed. And so, if anybody's interested, we'd love to have a conversation.
Hopefully, some of these cities all over the world. I heard there's one in Alberta downtown. They're trying to be net zero. So hopefully they can incorporate some of the to their building standards and codes or into their new developments to achieve that net zero. As
We'd
well
love to help.
as what about greenhouses? Would your technology work for greenhouses?
It depends on what you're growing. So, I mean, we're going to filter out certain parts of the light spectrum that might be detrimental to certain crops. So, it really does depend a little bit on what's underneath the glass and what sort of access and parts of the spectrum they need access to, because we will filter out certain things that might otherwise be necessary for productive growth in a greenhouse.
Well, Jonathan, this has been an incredibly insightful look into the exciting world of transparent solar cells. Thank you for sharing your expertise and the work of Next Energy Technology with us.
Absolutely. Thanks, Ali. It was a pleasure to be here.
And to our viewers, thank you for joining us on Clean Titans. Please subscribe and follow us for more insights into the cutting edge of clean energy technologies. Until next time, stay energized and keep innovating.